I've caught all of the existing builder classes up, so now we're going to generate the repetitive half of the builder classes. When I first started generating builders, I was using T4 templates, and while the T4 engine can generate valid .NET Core code, or really anything for that matter, it does have a problem in that it can't perform reflection over .NET Core assemblies, at least not yet. That could change in the future, but I'm going to focus on what we have right now and use Roslyn-based C# script files. There are complexities I won't go into here, but you can think of C# scripts like an old-school BASIC program that simply runs from top to bottom. We're going to use this to build a new .cs file. To get started, we just need to add a new file with the extension .csx. Then we'll add in some boilerplate. All this code does is output a plain old string. The $sign enables string interpolation, and the @ marks it as a verbatim string, so we can put line breaks in this header in order to see what we're doing. I'm sure you've seen headers like this on generated files many times before. C# scripts need something to run them, a hosting environment, and unlike T4 templates, Visual Studio doesn't know what to do with them on its own. I can't simply right-click on a CSX file and say Run Template. Fortunately, there's a NuGet package that will take care of this for us. From the Package Manager console, or from the UI, we'll add the scripty.msbuild package to our unit test assembly. Then all we need to do is build our solution, and the file will be generated. It's not magically made part of the project though, so we'll need to turn on View All Files and add the generated file to the project. Then we can turn it back off again. That's it. That's our starter. Let's add one more line to the template and rerun it to see the updated code. We'll need to add it inside the quotes, since all this template is doing is outputting one giant concatenated string. We'll put a using system in here, and then I'll rebuild the solution again. Now, every time we build the project, the builders.cs file will be automatically updated. That's great, but it's not really doing anything so far. Also, it's just a big string, so we don't get any kind of IntelliSense. But that's easy to fix. Let's break out of the string and start adding functions. Since this is just a string, we should be able to use string interpolation to inject strings created by other functions. So let's add one of those now. Below the using system line, we'll add a blank line and then a call to the buildTypes function. We haven't built that yet, so outside the string, we'll create a new function and call it buildTypes. Now we have our IntelliSense back, so that should make this easier to work on. The buildTypes method is just going to return a string, which will be injected into the template at the appropriate place. To test that this is working, let's just return a string containing a comment. And if we run the template again, builders.cs gets updated with the new comment, so everything's working pretty well so far. In order to output code for our models, we are going to need to do some reflection. So the first thing we need to do is get a hold of our base model class. So we'll get a hold of the model's type, and then we'll try to return the full name of that type as the comment. But if we rebuild, nothing changes. Let's see if we can find out what went wrong by looking at the error list. Because of the build order and the way the templates are evaluated, sometimes the errors can lag behind by one build, so you might need to be patient and it might not always be perfectly in sync with your code. But once the template's done and working, we won't really need to worry about errors from the template itself anymore. When the error list populates, you'll see that it's unable to find the store namespace. Just because this script is part of our project doesn't mean that it knows its way around. Remember, this script isn't really part of the assembly. It's being run by an external tool, and that external tool doesn't know anything about our project structure. We can add a reference to our domain project, though, with the ~r preprocessor directive. This will let us add a reference to an external assembly. You can use this to bring in tools that you need, such as external libraries. we're going to use it to add a reference to the domain assembly. The path will need to be relative to the script file. So looking at our Solution Explorer, I can see that I'll need to go up 1, 2, 3 directories, and then back down to the store domain project to get what I'm after, which is the output folder. So my complete reference is ... to move up the 3 folders, store.domain to go into that project, and then bin, debug, .NET Core App 2.2, and that'll change depending on the version of .NET Core that you're using. And finally, store.domain.dll. If I run the template again, I should get some output, listing the full name of the base type for our models. Before we go any further, let's make this a little more robust and add some error handling for when things go wrong. I'll add in a string builder as well, so I'll need to add a using system.txt to the top of the file, just below the reference directive. There are a few other namespaces you're going to need shortly, so let's just make sure they're all here. If you don't include all of these namespaces, then the things I'm about to show you won't work, and the exception messages you get aren't always the most helpful. So do yourself a favor and add all of these now. We'll have using system, using system collections generic, using system link, using system reflection, and using system.txt. Then we'll surround our code down in build types with a try-catch block and simply append the exception as a comment in the output. Now that we can see when something goes wrong, let's try using reflection to get a list of all of the model types. We'll grab the model assembly and then try to pull the types from it. When we rebuild, we'll get an error. Fortunately, I was expecting this one, and it's just a quirk of reflection on .NET Core. Even though I asked for just the types defined on the model assembly, some of their references came along for the ride and caused a problem. We can filter them out easily enough, though. First, let's define the model assembly types variable separately from its assignment. Then we'll wrap that assignment in another try-catch block. The catch will be looking for a very specific exception type, reflection type load exception. We can extract all of the types we really wanted in the first place from that exception. It looks like this. Basically, we're going to look in the types property of the exception and grab all of the types that aren't null. So in other words, all of the types that it was able to successfully pull out of that assembly. So next, let's see what we got back. We'll add a for each loop down here to go over each of the model assembly types and append their full name to the output. If we rebuild now and look at builders.cs, you'll see that there are a lot more types here than we actually need, including generic and abstract classes that we don't really want to build builders for. So we'll whittle it down a little bit before going any further. Here we'll use a where clause to filter out any of the generic type definitions, any of the abstract classes, and then filter it down to classes that inherit off of our base model class. Let's sort those by name, and then we'll output that to the list. We'll rebuild again. And that's more like it. We're just looking at the models we actually want now. The next step is to generate the shell of the partial class for each one of them. I'll just utilize this for each loop to generate the class definitions. I'm going to pull out a few properties that we're going to use multiple times into variables. We'll need the type's name. We're going to need the full name. And then we'll concatenate that together with the word builder to come up with the name of the builder class that we're creating. I'll just point out a few things about this code. We're decorating it with a generated code attribute, which will stop certain code tools from including it in their analysis, since it's not handwritten code anymore. Then we're creating the first line of the class. You'll notice that the brackets are doubled up. That's because we're already inside an interpolated string, and single brackets would mean that we want to substitute a value there. If we run this template and look at the output, you'll notice that the generated code attribute isn't resolving correctly. I can just add the missing using statements, but of course it will disappear on the next run, so let's take that using and copy it into the template. Since we've never specified a namespace for these classes, the compiler isn't properly associating them with the partial classes we made earlier. Let's fix this now by adding a namespace. If I examine the generated code, you can see that the classes I've already defined by hand are pretty happy. But classes like Category Builder won't build because there's no partial class that implements the build method. Let's tackle that next.